Units and measurements. Units and measurements. Physical quantities are represented by PQ, the quantities which can be measured by an instrument which describes the law of physical world. PQ can also be termed as a number with a unit, n into u. Number is a numerical value and unit is a comparison among other units, such as kilometer has a deeper comparison with meter and such. Number of times the unit. Numerical values also show the number of times the unit is. Weight of an elephant compared to a goat. Weight of an elephant compared to a goat is 150 times the goat. So here the unit is elephant and the goat. So if elephant weighs 150 times the goat, which means the elephant can be represented as 150 W goat. Now W human is equal to 2 goats. So here the human is a greater value than the goat, and here the elephant is a much greater value than the human. These are according to values, and here elephant and human are not any quantities which are used as a unit. They are only a reference to unit for a better understanding. Types of physical quantities. There are 3 types of physical quantities: fundamental physical quantities, derived physical quantities, and supplementary physical quantities. Fundamental physical quantities are the following: length, mass, time, temperature, electric current, luminous intensity, amount of substance. These are the unit which are there from the first. These are natural units. Then we come to their units. Length has a unit which is meter, mass is kilogram which is kg, time is second which is s, temperature is Kelvin which can be represented by K or a theta sign. Electrical current which is ampere which is represented by A, luminous intensity mole which is MOL, luminous intensity is candela which is represented by CD, and amount of substance which is mole represented by MOL dot. Derived physical quantities. These are the physical quantities which are made from the basic fundamental quantities which are here. So a derived physical quantity is made from the fundamental physical quantities. We have to use one physical quantity more than one time, or two physical quantities or more than two physical quantities in a sequence in order to produce a derived physical quantity. A physical quantity is made from basic fundamental quantities. Supplementary physical quantities, this is the third type. It doesn't have any explanation at all. Physical quantities are called supplementary when they are not derived, or either they are not made, they are just given, such as plane angle or an angle. Angle doesn't have any unit, so angle can be written as 180 degrees equal to pi. Here radian is the unit for angle, and solid angle 3D. A cone of an ice cream is a representation of a solid angle. So the angle which is formed by the cone at this point will be a solid angle or a 3D angle. Now we come to dimensions. What are dimensions? Dimensions not in the terms of 1D, 2D or 3D. Here are dimensions such as length, which is L, mass, which is M, time, which is T, temperature, which is K or a theta, I explained it earlier, or temperature as K or theta, electric current as ampere A, luminous intensity as CD, candela, amount of substance as mole, dimensions and the other powers to which the fundamental units are raised in order to express the derived unit or quantity. Dimensions of physical quantities. Area meter square, which is length into length, because meter is a representation of length, and here m square means length into length, which term as L square. So here if we represent this, we will write it as m0 because the mass is 0 here, the length is 2, we found it here, and the time is 0. It has no connection to time right here. The volume m cube, length into length into length, 3 times the length. So as earlier, m0 L3 T0. Density kg by meter cube, m by L cube. Kg is mass and meter is length. Here cube transfers to length cube. m1 because there is mass, L minus 3 because there is L cube but it is down, means it is on the downside of the division, so it will come up and become minus 3, and here t is 0 because there is no connection to time. Velocity, displacement upon time. What is displacement? Displacement is length and time is t. So here there is L1 t minus 1 because t was down the graph, and m0 because there is no connection to mass here, L1 t minus 1 because here it will convert here, and m there is no connection to mass, so it will remain m0. That is the format. Writing m l t mx tx dx is a format. We need to write in this way. We cannot write l1 t0. We need to include m here. Whether it is having a power of 0, that doesn't matter. Speed, displacement upon time, I already did that. Speed and velocity are in terms of dimension analysis, they are same. Acceleration, change in velocity by change in time. Meter by s into s, change in time means s into s. Change in velocity means m, m0 L1 t minus 2. So these are the type of questions that I will be providing these, and here are some more things. Dimensions of some constants. We need not think that the constants which do not have any dimensions. Constants do have dimensions in some cases. For example, universal gravitational constant g m1 m2 by r square. Not all constants in physics are dimensionless. There are some which have dimension. Now this is a question of molar specific heat capacity. As we progress to another chapters, we will know their formula and know how to solve them. So thank you.